Alright, this is section 10.8. The natural logarithm function is just like another log function, but with a different base. What is the natural log and how do we use it? It's not any different than the regular log function, it's just a specific log function with a specific value for the base. The most important logarithmic function is the natural logarithm function. It's used in science and math to graph because graphing on a log scale is more manageable. And I kind of drew an example in class. Or maybe I didn't. I don't remember. It doesn't matter. It is important and you will use it a lot, especially if you study math or science. The number e is a number. It's a number just like 1, 2, 3, pi, radical 2, whatever. The number e will be used frequently in your math, science, and engineering career because of its special properties that you will learn in calculus and other courses. If you are interested, e is defined as the limit of 1 plus 1 over n to the n power. So that's going to look very familiar to the formula for compound interest, but that's what e is defined as. As n gets very, very big, e is going to be the value of that number, which is approximately 2.781828. So the natural logarithm function of x will sometimes be written as log base e of x, but you're usually going to see it written as ln of x or natural log of x. You will notice both of these buttons on your calculator. You'll probably see some of these buttons instead of your log buttons. Treat natural log of x just as you would treat the log base e of x, which means you can change bases to it. You can change bases from it. You can apply all the logs of logarithms to natural log of x just like you did to log of x. Don't get too hung up on ln of x. It's just a very specific base e. But all ln of x is the log base e of x. So when you start, if you need to rewrite it as the log base e of x, that's fine. But I want you to get into the habit where you can recognize ln of x by itself and do functions with it without converting it to a log function. Let's look at example 1. Find the natural log of e to the negative 2 power. So remember, the natural log of x is merely the natural log base e of x. So for now, you can rewrite it as the natural log of e to the negative 2 is equal to the log base e of e to the negative 2, which means e to what power equals e to the negative 2? Well, that's clearly negative 2. So again, to start, if you need to rewrite it like this, that's fine. But at some point, in fact in about 5-10 minutes, you're going to have to recognize this right away as negative 2. You will notice that the natural log of an e to the something power, these are inverse functions and they cancel out. So you're just going to end up with the exponent here. Find the natural log of 1. Let's see if you can do this one on your own. Alright, the natural log of x is the natural log base e of x. So natural log of 1 is equal to the log base e of 1. Which means e to what power equals 1? Any number to what power equals 1, the answer, of course, is 0. So remember, natural log is just like any other log function. All the properties still apply. So the log of any base of 1 is going to be 0. Let's look at number 3, e to the natural log of 5. So just as the natural log of e to something power were inverses, e to the natural log of something are also inverses. So e to the natural log of x is equal to x. Therefore, e to the natural log of 5 is 5. And again, by the end of these notes, I want you to be able to see this pattern right away and recognize that e to the natural log of x, they are inverses, and so they kind of cancel each other out, and you're just left with 5. Number 4, e to the natural log of e squared. See if you can do this one on your own. This is not meant to be a difficult problem. And go ahead and try it. Alright, since we just learned that e to the natural log of x are inverse functions, that means e to the natural log of e squared is going to be e squared. Now, you might have also tried it this way. If you look at the natural log of e squared, those are also inverse functions. So the natural log of e squared is going to be 2. So it's going to be e to the second power, which is the same thing. So there are two different ways you could have attacked that problem. Both would have yielded the same answer. Number 5, give the natural log of 2 equals 0.69 in exponential form. So you're going to rewrite this as an exponent. There's probably going to be an e in it. since the natural log of x is the log base e of x, e to the 0.69 is equal to 2. And that's your answer. So remember, e is the base of the natural log function. E to the 0.69 equals 2. So it's just like any of the log function. Hopefully you're at a point where you can kind of do this without having converted exponential form when you solve problems. But if you still need to do it for a little bit, please feel free to do so. Number 6, give the 6th root of e to the 4th equals 1.95 in logarithmic form. So you're probably going to have a natural log in there somewhere. So let's walk through this step by step. The first thing you're going to want to do is convert this expression to some exponent with a fraction. So the 6th root of e to the 4th is e to the 4/6, which you can reduce to e to the 2/3. So e to the 2/3 equals 1.95. Now what you're going to have to do is take the natural log of both sides, because that'll get rid of the e. So the natural log of e to the 2/3 is equal to the natural log of 1.95. So the natural log and the e here cancel each other out, and you're left with natural log of 1.95 equals 2/3. Alright, so you've converted this to logarithmic form. The log of what number equals what? Log of 1.95 equals 2/3. Example 7. Express natural log of 5 minus natural log of 4 plus natural log of 12 as a single logarithm. Now remember, just because it's ln doesn't mean it's any different than any of the log function. All the laws still apply. So let's see how these work. In applying the second law, and again, I don't expect you to remember these laws. I just want you to be able to apply them. Combine the first two terms into one. The natural log of 5 minus the natural log of 4 is equal to the natural log of 5 over 4 plus the natural log of 12. Now you see you have a sum of the natural log of two numbers, so you can multiply those together using the first law. 5/4 times 12 simplifies to 15, and that's your answer, the natural log of 15. So you can do the same thing with the natural log as you did with the regular log function when it comes to subtraction or addition or with a quotient or a product here. Now, remember, you can do this because the natural log appears in both of these. If it was natural log and a log base 10, you could not combine them. Let's go to number 8. 1/2 natural log of 4 minus 1. Express that as a single logarithm. So, first of all, we need to convert the 1 here to a function with a natural log. So, 1 is equal to the natural log of e. Again, that's e to the first power equals e. So, convert the 1 to the natural log of e. Now, let's use the third law. Let's move the 1/2 over to the exponent for 4, and you get natural log of 4 to the 1/2 power minus natural log of e. Alright? So, what's 4 to the 1/2? You can simplify that. That's merely the square root of 4. So that becomes the natural log of 2 minus natural log of e. Now you have a difference of two natural logs. You can combine them into one natural log of the quotient of 2 over e. So, to express it as a single logarithm, sometimes you'll need to convert integers to some expression with a natural log in it. In this case, if it were 1, it's natural log of e. If this were 2, it would be natural log of e squared. You get the idea. Alright, we have some equations. Natural log of x equals 1/3. Now, how do we get rid of the natural log of x? Remember the inverse. The inverse is e to the natural log of x. So you're going to take e to the power of both sides. E to the natural log of x equals e to the 1/3. So e to the natural log of x, since they're inverses, just gives you x. X is e to the 1/3 power. Go ahead and try number 10. It's very similar to number 9, just a little more math. Alright, take e to the power of both sides. Get e to the natural log of x plus 2 equals e to the 4th. This part cancels out, so you're left with x plus 2 equals e to the 4th. Subtract 2 from both sides, and x is e to the 4th minus 2. Now, this might be a somewhat unsatisfying answer, but if you take this value and plug it in here, you will see that it simplifies to e to the 4th, and the natural log of e to the 4th is 4. So it does work. Alright, number 11, e to the 3x equals 27. What's the inverse of e to the x? It's the natural log function. So you're going to take the natural log of both sides. Natural log of e to the 3x equals natural log of 27. Now we can we can cancel the natural log of e, so you get 3x equals natural log of 27. Now, let's multiply both sides by 1/3, and you get x equals 1/3 natural log of 27. You notice that it's not in yellow because you can simplify it further. You can move this 1/3 to the exponent to the 27. So, x is equal to natural log of 27 to the 1/3 power. So, you can take the cube root of 27, and that gets you your simplified answer, which is the natural log of 3. So sometimes when you divide both sides by a number, check to see that you can simplify this number here by moving the coefficient to an exponential position. And then sometimes you can reduce it even further. All right, last one, number 12. Try this one yourself and check your answer in a moment. All right, you're going to take the natural log of both sides, so you end up with x plus 1 equals the natural log of 7. Subtract 1 from both sides, and your answer is the natural log of 7 minus 1. So, this is just an introduction to the natural log function. You'll learn many more properties about the natural log and the number e next year and in calculus. But that's all for now. If you have questions about the natural log or anything else in Chapter 10, please email me, contact me, ask me, or post a message to the Facebook page.